Welcome back, class. We're going to be doing set 2 problems for chapter 5, lesson number 7. And we're going to start here on problem number 4. And I want you to understand that it's very important that you are able to visualize some of these problems. It's very difficult for us to simply think of, for instance, distance is equal to rate times time, and we're thrown information without sometimes just drafting it up. As you become more accustomed to these things, you'll be able to plug them in your head and create equations directly. But in the beginning, it is important. It's important to visualize so that you can understand why these things are. Math is a fairly visual science all to itself, because really we're quantifying, for the most part, things that we see. Obviously, we can quantify things that we don't see, such as negative numbers, or let's say temperature. We don't really see temperature, but in these cases, we're really dealing with things that are much more visual, and I think it's a very good start for us with algebra, particularly as it relates to equations and understanding the relationships of numbers and variables within an equation and how to build an equation, and then of course solve the equation. So let's go ahead and look at number 4. Draw a figure like the one on page 220 to illustrate each of the following statements. Well, the first thing we ought to do is go to page 220 and see what they're talking about. They're talking about a figure. Now, I can just tell you they're not relating to the illustration above, so you don't have to worry about drawing little boys and dogs talking to each other. It's really the figure that's on the left side where we have the 50, the 50, and the 50. So let's go back and understand that we have to use that particular method, or at least that type of illustration. And we'll start with A. It says, if a bus travels 55 miles per hour for 2 hours, it would travel 110 miles. So how could we illustrate that? Well, let's just take a look. And the other was what was it? Mr. Jones was traveling at 50 miles per hour. Now we can see 50, 50, and 50. There were three 50s. So in this case, we're told that a bus traveled 55 for 2 hours. So we'll just go in here and create two segments representing 2 hours. So there are two segments, and we know that for each segment, the bus was traveling at 55 miles per hour. So this would be an illustration that is that's similar to the one that we see on page 220, and we can see that if we simply added, of course, the 55 and the 55, we would get 110. Now, let's and remember, we're talking about distance is equal to rate times time. We were already told that there were 2 hours, so if I wanted to add on to this, I could say 1 hour here and 1 hour there, and I could just simply add these two together, right? And what would I have? Well, I would have 110. So you can see where all these components are related to one another. 110 being the distance, this was the rate, and this was the time. Okay, up here, actually the time, the total time, excuse me, is equal to 2 hours. So you can see how they're connected to one another in this simple illustration. Let's go over to B. It says, if a truck traveled X miles per hour for 4 hours, it would travel 4x miles. So here we have a variable. And variables are not bad. They definitely are defining things that we may not have every component or every unit of measurement that we would want, but we're told that it's traveled in X miles per hour. So it's an unknown. But we could still illustrate that. We can say it traveled 4 hours, so let's create 4 segments. These segments aren't perfectly equal, but we get the idea. So we have 1, 2, 3, 4. And the question is, what was the rate? Well, it traveled at X miles per hour. So we would just simply put an X into each one here. Now we don't know what this is. Again, this is the unknown. This is the unit of measurement that we don't have information, but we can express that as X miles per hour, and it traveled, well, we simply add these up the same way we added these two up, and we would have 4x. So it traveled 4x miles. You might say, well, what is 4x miles? Well, if we can determine what x is, or if we knew what x was, we would then be able to determine the distance. Now let's stop for a minute. And what is x anyway? Well, x in this case is the rate, is it not? Okay, so here's our distance. And here, I'll put a little equal sign actually. And then we know that there were 4 hours, right? T is equal to 4. Okay, so we sort of have a variable within the information. We don't have the full answer simply because we don't know the rate. And I know we represent the rate as the letter R, but in this case we're just saying that the rate is x. So how would this look in an equation? Well, it's simply, let's see, d, it's 4x, right? We have 4x, and that would be over here, x, which is r, right? And then 4 is the time. Is that not right? And that makes sense because x times 4 is equal to 4x. So it is equal. The only problem is we simply don't know what this is. So we can see where this makes sense. We could simply write this as 4x is equal to 4x. And without really having that other variable, we wouldn't be able to determine what the answer is here. So we do know we don't know the distance because we don't know the rate. So they're in a sense two unknowns here, but it's being plugged into an equation where if we knew what the actual rate was, well, we would be able to determine the distance. Now, it really just goes back to this original equation, but it's good for you to see it in with the x variable, and that's going to develop itself over time as we start using the letter x to represent things. But ultimately, you're going to see where we're going to be using variables that will help us to better understand which variables we're looking for. That's why we have d is equal to xt. Why didn't we just simply say x is equal to yz? Okay, well, it's hard to understand that maybe z means time and y means the rate and d means the distance. But it's going to be okay for us to represent values using these variables. Let's move on to letter C. If a plane traveled at x plus miles per hour for 3 hours, well, it would travel 3x, or parentheses, 3x plus 30, and parentheses, that's the expression. It would travel that many miles. So what would that look like? Well, let's go ahead and create our 3 different segments. And here we have, now we're told these are each 1 hour. And what's the distance of each? Well, it will be x plus 10. Now, as you can see that there's some complexity here that we're building upon. We don't know what the rate is, and sometimes we're working with bigger problems, and those bigger problems are giving us information, and so now we have to go and rely into, well, we got to determine what d is, or we have to determine what r is, so that we can solve this other equation, because it's all part of a bigger puzzle. And sometimes we simply have variables. In this case, we had x. We have x plus 10, we had x before, but we can again represent the rate, and we can treat this as we would if we even knew the variable, such as up here we had 55. So what would we do? Well, we would multiply this by 3, or we can simply add them all together, and we would have a distance of 3x plus 30. Okay, and again, we can either multiply them and apply the distributive rule, 3 times parentheses x plus 10 and parentheses, 3 times x would be 3x, and 3 times, let me just draw it over here so you can see it better, 3 times x and 3 times 10, that would give us 3x plus 30. But again, we're sort of left hanging out there without really knowing what the rate is, because part of the rate is a variable. But at least we know how we can treat that variable within its relationships with other variables or with other components, such as, let's say, distance. Well, this is the rate, so it would be distance and time. Okay. Now, we're going to move on to number 5. Actually, we'll do another video for number 5.